Okay, so this is going to be your notes for today. Let's analyze here 9.2 and 9.3. So we are going to really introduce this idea of logarithms today. So first of all, we have x, and then we've got log 10x. Okay, so x and log 10x. So what this table shows us is that when we plug in a single value, say 2, 3, 4, 5, 6, all the way to 10, we're plugging this into the x here. So you can see 2 times, or if you have 2 in here for x, so log 10 of 2 is 0.3010. Log 10, base 10 of 3 is 0.4771. And that continues all the way through. So notice here in this column, it's all increasing by 1. But if I jump over here to this column, it increases by tens. So log 10 of 20, log 10 of 30, log 10 of 40, all the way down to log 10 of 100. And down here, it increases everything by 100 until it gets to log of 1,000, log 10 of 1,000. And then over here, increases by thousands until it gets to 10,000. So the next one would kind of increase by 10,000s until it got to 100,000s, and then we could continue that trend. But also notice at the very last row in each of these columns, log 10 of 10 is 1, log 10 of 100, log 10 of 100 is 2, log 10 of 1,000 is 3, and log 10 of 10,000 is 4. Okay, so this is just some table of numbers that we have, and we're analyzing and discussing with the people around us or ourselves what we think the table tells us. So what this actually tells us is the exponent you raise 10 to get x. So this tells us the exponent, man, I wish this was a left-handed mouse. The exponent you raise 10 to get x. So you might be thinking, how does he know that that's what it gives us? Well, think about 10 to the power of 1. What's 10 to the power of 1? Oh, it's 10. So I raise 10 to a power of 1 to get 10. I raise this 10 to the power of 2 and I get 100. I raise 10 to the power of 3, 10 times 10 times 10. So 10 times 10 is 100, times 10 is 1,000. 10 to the power of 4 gives me 10,000. So the exponent you are raising 10 to get x is what this table tells us. All right? So using the table, find the values of the unknown exponent to make the equation true. So A, 10 to the what power gives us 1,000, right? So we actually look in this column and we say that that would have to be 3. 10 to the power of 3 gives us 1,000. Well, 10 to the power of what gives us 9? 10 to the power of what gives us 9? Now, this one's a little tricky, right? So where am I going to get a 9 for y? Right here. So what would my power be? 0.9542. Okay. 10 to what power gives me 90? 10 to the power of 1.9542. And you can also notice that all the decimals that follow that whole number are the same as well. But just something else to notice. All right, so notice that some of the values in the columns labeled log 10x are whole numbers, but most are decimals. Why do you think that is? All right, so the reason that this is because there are only pretty numbers that will be multiples of 10. So the only pretty numbers that we have, in other words, the only whole numbers we have, would have to be a multiple of 10. 9 is not a multiple of 10. 6 is not a multiple of 10. 16 is not a multiple of 10. So you're going to have very limited multiples of 10. And the way that you find those multiples of 10 is if that would be the power. Okay? So when we think about this in the sense of they have to be the power to get there, 10 to the power of 1 gives me 10. 10 to the power of 2 gives me 100. 10 to the power of 3 gives me 1,000. None of those powers from before are going to give me nice numbers. So why do you think that is? Because the only nice numbers we have would be when that value of log 10x is a power of x. Okay? Let's go down here and say hello to logarithms. So hello logarithms. What is a logarithm? Well, let's take a look here at the two true equations. We know that these two are true because it tells me they're true. So here are two true equations based on the information from the table. The log 10 of 100 is equal to 2. Log 10 of 1,000 is equal to 3. What values can you replace the question mark with in the equations to make them true? So essentially it's like an X. What would I plug in for question mark to get the right answer, right? So log 10 of 100, or excuse me, a million, what would make that true? Okay, log 10 of 100, what would make that true? So think to yourself, what exponent would I raise 10 to get a million? The answer is 6. Okay, but maybe you don't want to think about that. And for some reason, I don't know how to change my screen. What does this button do? Oh, it flips me. That's cool. Wop, 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 wop. All right. Let's see. Do you follow me? I want you to follow me. Okay, so I guess you're just going to record this tab. But if you go to Desmos and go to your logarithmic, or you go to your scientific calculator, and I'm jumping over there now, there is a function called log, okay? And it'll say log, log base 10 is on all of them. So they're all really log base 10. But if you were to say log of a million, it goes to 6. Okay, so all like functions give me log base 10. I think there is a way to change that. We'll talk more about that later. Anyway, so you could type in log of a million and it will give you 6 in for your answer. If you were to type in log 10 of 1, what power of 10 would I have to have in order to give me 1? This goes back to exponent rules. Anything to the power of 0. This is essentially like saying 10 to what power gives me 1. Here, this is essentially saying 10 to what power gives me a million. So this one is saying 10 to what power gives me 4. Ooh, I know. Let me go back up to my table. Where is 4? Oh, it's right here, right? That's when it's 4. X is 4, so then I know that my log 10 has got to be 0 or 0.6021. So 0.6021. Okay, between which two whole numbers is the value of log 10 of 600? Now let me just backtrack for a second. Don't go back to the table just yet. If I come up here and I look at 600 And then I go to maybe this right here on 9.3, and we see 100 and 1,000. Notice that 600 is between 100 and 1,000. So which two whole numbers would the log 10, or what would the value of x need to be in order to make this 600? Well, it's got to be between 2 and 3. Because our answers here are 2 and 3, I know that the number between 2 and 3 is going to give me the log of 600, log 10 of 600. So that's where we get that answer. All right. Now, the term log is short for logarithm. So discuss the following questions with me or somebody beside you. We'll talk about it and record your responses. What do you think logarithm means to do? Now, we've already really talked about this. Logarithm refers to the exponent to which a base number is raised. So a logarithm undoes a exponential. So log undoes an exponential. Write that down, pause it. It's hard for me to write with this, nice mouse, so I'm not going to write that out. If I could type it, I would. I don't know how to type. I don't know how I can type. Maybe I'll learn that later. But right now, what do you think logarithm does? It undoes exponentials. Next to log is a subscript. Subscript means the number underneath. A number or letter printed smaller and below the line of text. What do you think the subscript tells us? It tells us the base of the exponential. So like if it's log sub 10x, that is like saying 10 to the x. Okay, if it was log and the subscript was a 2 and we had an x, that would be like saying 2 to the x. So the subscript tells us the base of the exponential expression for which the exponent is unknown. Now the next thing says, what about the other two numbers on either side of the equal sign 4? For example, the 100 and the 2 and log 10 of 100 equals 2. Well, this actually tells me that 10 to the 2 equals 100. So we have a nice little cool thing here called around the world. If I take the 10 and I draw an arrow around, so we're going to say 10 is the new base, 2 is the new power, and it equals 100. Same thing. We could go around the world in the other way if we wanted to, but what it says, what this tells us, the other two numbers tell us the 2 is the exponent and the 100 is what it equals. Because log 10 of 100 is like, what would we raise 10 to get 100? Well, we'd raise it to 2. So this says log or 10 squared equals 100. That's the same thing. For example, if I had log 2 of, let's see, how about 4? We're saying what power do I raise 2 to get 4? Well, that would be 2. Log 2 of 4 is 2. How do I know that? I could also do this around the world, and I get 2 squared equals 4. And that's true, right? That's a true statement. Last thing here says, for which value or which whole number value of n does log 10 of n an integer? Okay, now this isn't are you ready for more? So, it doesn't have to be 100% here, but for which whole number values of n is log 10n an integer? We're going to say that these have to be whole number powers. For example, this is like saying, right, what power of 10 gives me a whole number, right? So which whole number values of n are an integer? Well, basically, these have to be multiples of 10 in this regard. Whole number powers of 10. So if n is 10, we get a whole number, right? If n is 100, we get a whole number. So they have to be multiples of 10 in order to get an integer or a whole number out, right? Integer just means that it's got to be a whole number. So any multiple of 10 would be the answer for Are You Ready for More? Multiples of 10. Write that down.